This is SpaceTime Series 25, Episode 38. Coming up on SpaceTime. Strange happenings aboard the International Space Station. Artemis crawling towards launch. And Ingenuity completes its 22nd flight on the red planet Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Three Russian cosmonauts have surprised the world, emerging from their newly arrived Soyuz capsule aboard the International Space Station wearing bright yellow and blue flight suits reminiscent of the colours of the Ukrainian flag. The three were the first new arrivals aboard the orbiting outpost since Russia invaded the Ukraine, triggering tit-for-tat sanctions between Moscow and the West, which have also halted most space programs involving Russia. The trio's Soyuz MS-21 capsule docked with the orbiting outpost after a 3-hour to-orbit fast rendezvous flight from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
The fuel lines and other elements of the rocket engines are being purged with nitrogen to fireproof them by removing vapors of fuel and oxidizer. Coming up shortly, the booster's fuel tanks will be pressurized for flight.
Pressurization initiated. Copy. We can see commander and flight engineer on our screens.
And the booster fuel tanks are now being pressurized for flight, and the ground propellant feed has now been terminated. Soyuz now on internal power.
Vehicle to internal power. Copy.
First umbilical tower has separated from the booster, and we have auto sequence start.
Auto sequence initiated. Ignition. Second umbilical
Launch command
tower
has been issued.
Engine turbo pump set flight speed. Engines at maximum thrust and liftoff.
Liftoff of the Soyuz MS-21.
So let's work in space together. All the parameters of the launch vehicle are nominal. Copy. Everything is well on board and the
30 seconds into flight, everything going as planned. At this second, the International Space Station is flying directly over the Baikonur Cosmodrome. Velocity is over 1,100 miles per hour.
Nominal. Copy. Everything is good on board. The crew is feeling well. The thrusters of the first and second stage are firing nominally. Everything is stable. Copy.
Continuing to hear good calls. Everything proceeding nominally.
Stage. Copy. First stage separation.
And the 4 strap-on boosters have been jettisoned.
150 seconds into the flight, the thrusters of the second stage are firing nominally. Copy. Jettisoning of the launch shroud.
Soyuz MS-21 as it continues its climb uphill, everything proceeding as planned.
150 seconds into the flight, the vehicle is stable. Copy. Everything is good on board. All the parameters are nominal. Copy.
210 seconds into the flight.
This stage will continue to burn until the 4-minute 43-second mark into flight. Second stage engine performing as expected.
Standing by for GK 2, second stage engine cut off command. GK 2, main engine cut off command confirmed. Second stage separation confirmed.
The core booster now separating.
310 seconds.
Soyuz now being propelled by the single engine of the Soyuz third stage.
Copy. Everything is fine on board, and the crew is feeling great. Onboard system parameters are nominal. Copy. 360 seconds into the flight. Pitch, yaw, and roll parameters are nominal. Copy, and the crew is feeling excellent.
Soyuz now traveling over 11,000 miles per hour. The next milestone that we'll be looking towards is third stage cutoff and separation, slated to occur at the 8-minute 46-second mark into today's flight. We're now 7 minutes and 20 seconds into the launch of Soyuz MS-21, headed to the International Space Station with 3 Russian cosmonauts on board. Now coming up on third stage shutdown.
Seconds into the flight, Getting ready for third stage separation.
530.
530 seconds into the flight.
Есть контакт отделения.
Stage 3 separation is confirmed. And congratulations on the successful orbital insertion, and I will...
And we have confirmation of spacecraft separation.
This is Moscow.
The Soyuz capsule and crew inside now are safely in orbit, and the spacecraft is automatically executing its pre-programmed commands to deploy the antennas and solar arrays.
Jones, this is MCC Moscow. How do you read me?
And we do have confirmation of solar array and antenna deploy.
Video initially showed the Soyuz crew during their final approach and docking maneuvers wearing their usual blue flight suits. But once docked and pressurization equaled with seals checked, they shocked everybody by emerging from the capsule dressed in the new yellow and blue apparel.
The Soyuz MS-21 spacecraft docked to the pre-shuttle module. Roscosmos cosmonaut Anton Shkaplerov working through procedures to open the hatch on his end. He's currently inside the Nauka module of the International Space Station. Both Anton Shkaplerov and Pyotr Dubrov inside the hatch, as well as European Space Agency astronaut Matthias Maurer. They're working together to open up the hatch. And the hatch is open.
So this is right. I guess I can hear Anton now. Go. That's right.
The hatch is open. Hatch opening occurring at 4:48 p.m.
All right. Hooray. All right. Go for it. All right. Go ahead. Go first, but be careful. What was that? Yes, go ahead. I'm going to finish up here.
First through the hatch was Korsakov. Next up is Denis Matveyev.
Yes, so are we going to transfer? And I'm signing off, correct? Yes, sounds good. Your go. All right.
And all three Russian cosmonauts are now aboard the International Space Station.
When asked about their fashion choice, the cosmonauts insisted there was no message intended. Sometimes yellow is just yellow. They claim the crew get to pick their own colours for the jumpsuit, and when it was their turn to pick a colour, they saw there was a lot of yellow material left behind, so they simply chose to use that. Tensions between Moscow and the West have been steadily growing worse ever since the 2008 Russian conflict in Georgia, and they began to accelerate even more quickly following the 2014 Russian invasion and then annexation of the Ukraine's Crimean Peninsula. Russia's latest invasion of Ukraine and scenes of civilians being slaughtered have triggered the biggest response yet from the West, which has included crippling sanctions and growing arms shipments to Ukraine. The European Space Agency has cancelled all joint space operations with Russia, including an Arianespace Soyuz flight which was slated to launch this week from ISS Kourou spaceport in French Guiana. Soyuz began flying Arianespace missions from Kourou in 2011, replacing the Ariane 4's Arianespace's medium-lift launch vehicle. Moscow's now recalled all 87 Russian personnel working at the European-owned Kourou launch complex, while ESA is now looking at rescheduling Soyuz payloads onto additional Ariane 6 and Vega C flights. Moscow's also switched off their telescope aboard the joint Russian-German Spectre RG high-energy space telescope, destroying years of scientific research. Launched in July 2019, Spectre RG is located 1.5 million kilometres from Earth in the Lagrange L2 position. That's a gravitational well on the opposite side of the Earth to the Sun. Spectre RG's instruments include the German Erosa X-ray Space Telescope built by the Max Planck Institute and the Russian ART-XC high-energy X-ray telescope, which is designed to detect supermassive black holes. Work on the joint European-Russian ExoMars mission to the Red Planet, which was slated to launch in September, has also been cancelled. The mission, which includes the European Rosalind Franklin Mars rover, was to fly on a Russian Proton rocket from the Baikonur Cosmodrome. The mission had already been delayed 2 years by ongoing technical problems and by the COVID-19 pandemic. And any further delays will mean another 2-year wait because of the need for a favourable Earth-Mars orbital alignment. Also scrubbed was the launch of a Soyuz from Baikonur last week, carrying OneWeb's latest batch of 36 broadband internet satellites. Moscow demanded the satellites not be used for military purposes and that the British government withdraw from its involvement with the OneWeb Corporation. Images showed American, Japanese and British flags being literally scraped off the Soyuz payload fairing. In response, the British government issued a statement saying it no longer made any sense to launch on any Russian rockets. Making matters even worse is nationalist Dmitry Rogozin, an enthusiastic supporter of the current invasion of Ukraine by Russia. He was appointed as head of Roscosmos in 2018 by his longtime friend and colleague, Russian President Vladimir Putin. Rogozin's retaliated to the sanctions by threatening to end cooperation on the International Space Station and ceasing to boost its orbit using Progress cargo ships. See, even at altitudes of 400 kilometers, which is where the space station orbits, there's still enough rarefied atmospheric molecules to cause some degree of drag on the space station. And that in turn causes its orbit to slowly decay. Space shuttles were originally used to regularly boost the space station back into a higher orbit every time they docked, and that task was taken over by Russian Progress cargo ships once the space shuttle was retired in 2011. Rogozin also threatened not to return NASA astronauts to Earth aboard Soyuz spacecraft in retaliation for the sanctions. But so far he's not followed through on either of those threats, and the space station's operations appear to be normal. However, Rogozin has halted delivery of any further Russian-built RD-180 rocket engines to the United States. Since the mid-1990s, some 122 RD-180 engines have been ordered from Russia for use on American Atlas V rockets by the United Launch Alliance. So far, 98 of them have been used, with a further 24 waiting to be installed. However, Russia will now no longer supply these engines, nor will they maintain and service the remaining ones yet to be used. As for the yellow Russian flight suits on the latest crew aboard the space station, it's still not known what the real political ramifications of that were, if any. Normally, cosmonaut activities are choreographed very carefully by political powers. So I guess we will never know whether or not this was really a message of support or simply a coincidence. But it is interesting. This is Space Time. Still to come, Artemis 1 crawling towards launch, and Ingenuity completes its 22nd flight on the red planet Mars. All that and more still to come on Space Time. Last week's historic rollout of the giant Space Launch System Artemis 1 moon rocket would not have been possible without one of the unsung heroes of NASA's manned space program, its giant crawler transporters. Formerly known as the Missile Crawler Transport Facilities, these 40-metre-long 2,722-tonne mobile platforms are used to transport the world's largest rockets from NASA's Vehicle Assembly Building at the Kennedy Space Center along the 6.5-kilometre track to Space Launch Complex 39 at the Cape Canaveral Space Force Base in Florida. The system's very different from the Russian system of using giant railroad vehicles known as Schnabel wagons, hauled by locomotives to transport Soyuz and Proton rockets horizontally to the launch pad, where they're then raised into a vertical position. When NASA built their two crawler transporters in the 1960s, they were the largest self-propelled land vehicles in the world. They were specifically designed to carry the Saturn 1B and even bigger Saturn V Apollo moon rockets. Much of their technology was based on the heavy-haul railroad and mining industry. Each transporter is mounted on 8 Caterpillar-like crawler tracks, similar to those employed on some of the world's biggest bucket wheel and dragline excavators. Each track has 57 shoes, and each shoe weighs 900 kilograms. The crawler transporters are each powered by two 2,050 kilowatt, that's 2,750 horsepower, Alco 251C V16 diesel engines. They're the same engines used in Alco Century C628 mainline diesel locomotives. The crawlers are also equipped with a further two 794 kilowatt, that's 1,065 horsepower, auxiliary engines, which drive generators supplying power for all auxiliary systems, including jacking, steering, lighting, and ventilation. Following the end of the Apollo program, they were rebuilt during the late 1970s to transport the space shuttles to pads 39A and B between 1981 and 2011. Their latest reincarnation has seen one of the two units, CT2, rebuilt again, this time to haul the huge Artemis Space Launch System, or SLS, the world's largest rocket. The two crawler transporters were added to the National Register of Historic Places in the year 2000. One of the many milestones in the lead-up to the launch of Artemis 1 was the spectacle of the rollout, as the giant crawler transporter carried the SLS rocket, complete with its Orion capsule and European service module, from the vehicle assembly building onto Launch Pad 39B. ECTV spoke to NASA's John Giles about the crawler transporter and the adaptations made to this historic machinery to handle the SLS.
Hi, I'm Kelsey Brennan-Wessels, and the European Space Agency, together with our partners at NASA, are getting ready to return to the moon. We are in the United States, in the sunny state of Florida, at Kennedy Space Center.
ESA is playing a key role in NASA's Artemis program, which will bring astronauts back to the moon. The European Service Module, or ESM, will provide propulsion, power, and thermal control for the Orion spacecraft. When the first Artemis mission launches on an SLS rocket this year, ESM-1 will guide an empty spacecraft into orbit around the moon in a test of what's to come. There are countless steps in this journey to the moon, but one of the major moves before launch is getting the hardware from the vehicle assembly building to Launch Pad 39B.
This is crawler number 2 here. She was built back in the 1960s, mid-1960s, for the Apollo program. And she's handled Apollo and Skylab and Shuttle, and now she's going to be the crawler of the future for SLS. And she's been modified over the years for the different programs. And for SLS, we've had to modify her, we've had to increase her carrying capacity by 50%. So we spent a few years doing that, and then the last few years we've been getting her ready by taking the mobile launcher back and forth to the pad and doing a few other tests around here. She herself, I know this is rude, but she weighs 6.75 million pounds. We'll carry a mobile launcher that weighs 11.4 million pounds, and then we'll carry the SLS launch vehicle, which is somewhere around 3.5 million pounds. So add that all up, and that's what we'll carry back and forth to the pad. And then with each mission, as the launch vehicles get bigger, heavier, bigger second stages, and bigger cargos, bigger solids, the weight just keeps going up. Our speed to take SLS to the pad is going to be 0.83 miles an hour. That's the speed they determine will give the rocket the smoothest ride.
The distance from the vehicle assembly building to Launch Pad 39B is about 4.2 miles, or 6.75 kilometers.
People don't realize it, but what we're carrying does move around a lot. So those gel cylinders we have the great task of keeping everything level. We actually have engineers that are trained to keep it level, and then we have a system that also works to keep it level. So as we roll to the pad in the middle of the night, we'll get there, we'll roll up the pad slope, we'll drop it off, and then we will roll back down to the bottom of the hill. And that's where we'll sit, right outside the gate, and they'll start performing tests. And we'll stay there for as long as they need us to, and it's usually until a day or two before launch, until they know everything's in great shape and they're ready to launch. Then we'll roll back to what's called the MSS Park site, and we'll stay there. And so if they need us for anything, it's just a few-hour ride to get back to the pad.
As John mentioned, the crawler has a history in transporting lunar missions, but adaptations were needed to prepare for this one.
They were originally designed for 12 million pounds. The requirement for SLS was 18 million pounds, so it's a 50% increase. Each corner, we call them a truck. So the truck consists of 2 of these tread belts, 57 shoes each. Each shoe weighs over 2,000 pounds, and they roll across 11 very large roller bearings underneath that we replaced when we modded this. So we made them bigger and stronger so they could handle the extra weight. Right behind here we have a gearbox. There's 16 of them on the crawler. They were all rebuilt. All the bearings were replaced in them. And then that is connected to the chassis by 4 very large hydraulic cylinders that we call gels. Stands for jacking, equalization, and leveling. Each one of these trucks can turn. We can rotate them. They have 4 steering cylinders that rotates them. They can turn. We try to keep it within 6 degrees. And then we need that turning radius so we can get around the turns from here to the VAB and out to the pad. We're looking down at one of the truck, one of the big steering arms. You see all the electrical cabling that goes into the motors that turn the gearboxes and propel us. And then this large thing right here is a steering cylinder. There's 4 of those attached to each truck. Each truck weighs 1 million pounds, so that's why it takes 4 of these large cylinders to turn it. And then right behind us here, we have 2 of the jacking, equalization, and leveling cylinders. These are very large hydraulic cylinders. They go down all the way into the base of the truck. They're, I believe, I want to say 20 feet deep, and they can extend up to 26 feet. There's 4 of these on each corner, and they're bigger than the original one, so they can handle the extra weight. So inside here, you have one of the cabs where the drivers will be. There'll be at least 2 in there. One is actually driving and one is sitting in the sort of the co-pilot's chair. Everybody is on radios during the roll. Everybody's connected to each other. Everybody can talk to each other. The drivers, the engineers, the mechanics, the technicians, they're all in contact. They're all on the same net. I have a fuel tank here. 2,500 gallons of diesel fuel. We have 2 fuel tanks, one on this end, one on the other end. So we carry 5,000 gallons of fuel with us at all times. Our goal is to never stop while we're rolling. We have bathrooms on board, microwave, you eat your lunch, your dinner, your breakfast, everything is on board here. We try not to stop. If we stop, something probably didn't go the way we had it planned and we got to fix something. It's a wonderful piece of machinery. If you're an engineer, this is the greatest thing ever.
That report from ESA TV. Sometime during the next month, the SLS will undertake a fully fueled dress rehearsal for the long-awaited Artemis 1 mission. Artemis 1, which is now slated for sometime in May, will carry an unmanned Orion capsule around the Moon and beyond and then back to Earth again. It'll test the performance of the SLS rocket and the Orion spacecraft and systems. Orion will fly further than any spacecraft built for humans has ever flown before. In fact, it'll travel some 461,000 kilometers from Earth, thousands of kilometers beyond the Moon, over the course of its 3-week mission. This is SpaceTime. Still to come, NASA's Mars Ingenuity helicopter completes its 22nd flight over the surface of the red planet. And later in the science report, a new species of ankylosaur dinosaur discovered in China. All that and more still to come on SpaceTime. NASA's Mars Ingenuity helicopter has completed its 22nd flight over the surface of the red planet. The 101.4-second flight reached altitudes of over 10.5 meters. The 6-wheeled car-sized Perseverance rover, with a helicopter tucked neatly inside its undercarriage, landed in Jezero Crater in February 2021, 13 months ago. The primary mission of Perseverance is to search for signs of past microbial life on Mars and study the crater's geology, collecting samples for eventual return to Earth. Ingenuity was meant purely as a proof-of-concept demonstrator, designed to fly just 5 flights on the red planet's surface. It's now flown some 22 flights covering almost 5 kilometers and has logged more than 40 minutes of flight time. The next phase of the mission will see the 2 spacecraft, Ingenuity and Perseverance, travel to a nearby ancient dried-up river delta which contains vast deposits of sediment which have been washed down from further upstream billions of years ago. Scientists believe this will be one of the best places to search for signs of past microbial life on Mars. That is, of course, assuming it ever existed. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.